Jengker, and then Bukit Tarik, new one. And this is basically, all these are basically experimental catchment and forested catchment. But Sedenak, very close to UTM, is basically hydrological study in oil palm plantation. That is basically the focus of the study, mostly looking at the impact of forest operation, except the one in Sedenak, which is basically looking at the hydrological effect of forest oil palm plantation. There are also a few studies in Sabah and Sarawak. I would like to take this opportunity to highlight forest hydrological cycle, because most of engineers are very familiar with urban hydrological cycle. But I think it is more interesting to see what is happening in the forest. So, in the forest, once rainfall, it will be intercepted. Intercepted by the canopy until the canopy storage are exceeded, then true fall will start. And very small percentage, about 1%, will flow to the ground as stem flow. So the amount of water intercepted by canopy is between 15 to 20%. And 80% is basically as true fall, which is basically water that is dripped off from the canopy. Very important point is that once the rainfall reaches the forest floor, most of the water will be infiltrated. And then water will move laterally with the bedrock as subsurface flow. A very small amount of overland flow actually can be observed in the forest. In fact, less than 1%. If you have the opportunity to stay in the forest during heavy rainfall, normally you will not be able to see any overland flow on the surface, except if you observe that near the channel margin, where the soil is very saturated. Otherwise, we will not be able to see overland flow, because most of the water moves underneath. Most of the water moves underneath. So this is very important to differentiate between the disturbed and undisturbed catchment. Another important thing is that combined loss through transpiration from the stoma and wet evaporation from the canopy, that normally account for about 1,400 millimeter